Application of polarization, application of Fajan's rule. Okay, application of polarization. That means application of Fajan's rule. The polarizing power of cation depends upon ionic potential, which is expressed as ionic potential. The polarization, the polarizing power, the polarizing power of a cation depends on ionic potential. Depends on ionic potential. Ionic potential, which is expressed as phi. Okay, phi ionic potential, phi equal to charge on cation, upon radius on cation, that is Z positive ions upon R positive ions. Higher will be the value of phi, more will be its polarizing power. Higher will be the value of phi, that means ionic potential. Higher will be the ionic potential, more will be its polarizing power. More will be its polarizing power. Okay, more will be its polarizing power. If two elements have same ionic potential, if two elements have same ionic potential, their chemical properties are also similar. Their chemical properties is also similar. Okay. First point, covalent character in ionic bond. Covalent character in ionic bond. First point, covalent character in ionic bond. Okay. Higher will be the value of ionic potential. Of cations. Their polarizing power are 10C. To form covalent bond will also be more. Their polarizing power is more. Okay. Form covalent bond will also be more. Polarizing power increase from left to right. Polarizing power increase. Polarizing power increase from left to right. Polarizing power increase from left to right in a period. Okay, and decreases, and polarizing power decreases from top to bottom, from top to bottom, from top to bottom, top to bottom in a group, in a group, okay, in a group, periodic table, in periodic table, in periodic table, okay, in periodic table. This is because the order of ionic potential of cations is the same. This is because the order of ionic potential, the order of ionic potential of cations is the same. Of cations is the same. Cations is the same. Okay. For example, 5 values of ions. Sodium positive ions, magnesium positive ions, and aluminum positive ions. 1.04, 3.06 and 6.9 as covalent property in their oxides is in the following orders: Al2, O3 is greater than, MgO is greater than sodium oxide. Okay, this is the covalent property in their oxides. Covalent properties. Covalent properties. Okay. Second point, second application, diagonal relationship. Diagonal relationship. Diagonal relationship. Second point, diagonal relationship. Second point, diagonal relationship. Those elements which have almost the same phi values show diagonal relations. Those elements which have almost the same phi, which have almost same phi values, which have same phi values show diagonal relationship. Show diagonal relationship. 5 for barium positive ions is 2 upon 0.31 equal to 6.4, and 5 for aluminum triple positive ions is 3 upon 0.50, that is 6, are almost same. Are almost same. Hence barium and aluminum show diagonal relationship. Okay. Those elements which have almost the same phi value, that means ionic potential same. Those elements that have same ionic potentials values show diagonal relationship. For that means ionic potential for B double particle 2 upon 0.31 is 6.4, and 5 for aluminum triple particle 3 upon 0.50, that is 6, are almost the same as beryllium and aluminum show diagonal relationship. Third point, melting points of compound. Third point, melting points of compound. Third is melting points of compound. Okay. Third point of use of Fajan's rule of third point. Melting points melting points of compounds, melting points of compounds. Covalent character increases in ionic compound by increasing polarizing, consequently melting point decreases. Okay, covalent character increases. Covalent character increases. Covalent character increases in ionic compounds. In ionic compounds by increasing polarization. By increasing polarization, consequently melting point decreases. Molecules charge on cation, melting point. Okay. Covalent character increases in ionic compounds by increasing polarizing, consequently melting point decreases. Okay, that is a melting point. Molecules, sodium chloride, positive, one positive ion, magnesium chloride, double positive ions, and aluminum chloride, triple positive ions. That is a melting point is 800 degrees Celsius. Melting point of magnesium chloride 21.5 degrees Celsius, and aluminum chloride sublimation. Fourth point, solubility. With the help of polarization, comparative study of properties of compounds and their explanation can be done. For example, among the chlorides of alkali metals, only lithium chloride is soluble in organic solvents. This is because small cations of lithium positive ions polarize more chloride ions, so more covalent character develops in lithium chloride. That is why lithium chloride is soluble in non-polar solvents, that organic solvents. And with the help of polarization, comparative study of properties of compounds and their explanation can be done. For example, among the chlorides of alkali metals, only lithium chloride is soluble. Lithium chloride is soluble in organic solvent. This is because This is because small cations of lithium positive ions polarize more. Chlorine negative ion show more covalent character develops in lithium chloride. That is why lithium chloride is soluble in non-polar solvents, that is organic solvents. Okay. Fifth is color. High value of polarization is responsible for development of color in organic compounds, because silver chloride is white, that means चांदी chloride is white, while silver bromide is pale yellow. The size of bromide is greater than the size of chlorine ions. The silver bromide is more polarized than silver chloride. High value of polarization is responsible for development of color in inorganic compounds. Silver chloride is white, while silver bromide is pale yellow. As the size of bromide is greater than the size of chlorine negative ions. Okay, thus silver bromide is more polarized than silver chloride. Thus silver bromide is more polarized than silver chloride. Okay. 6 point, nature of bond. Aluminum fluoride AlF3 is ionic, but aluminum chloride is covalent. Aluminum chloride is covalent due to bigger size of chlorine negative anion, which is easily polarized, which is easily polarized Aluminum chloride is covalent. Covalent. Okay. Aluminum chloride is ionic, but aluminum chloride is covalent. Due to bigger size of chlorine negative ion, which is easily chloride, silver chloride is covalent. Next is metallic bond.